You ever watch a superhero movie and just think to yourself, man, could that really happen? Well, today, that's exactly what we're going to do. We're going to take those epic, larger-than-life moments and use them to understand some pretty huge ideas in real-world physics.
And let's start with the big one, a real classic scene you've probably seen a dozen times. The hero planting their feet, muscles bulging, trying to stop a runaway train. So what does science have to say about that? Is this even possible, or is it just pure Hollywood fantasy?
All right, to really get to the bottom of this, we need to focus on maybe the most famous example of this. Our case study? None other than your friendly neighborhood Spider-Man.
Okay, you know the scene. Peter Parker, no mask, digging his heels in, trying to stop this out-of-control elevated train full of people. He shoots out web after web, you see them stretch to their absolute limit, and somehow he pulls it off, bringing this massive thing to a stop just in the nick of time. It's an amazing moment. But seriously, how strong would that webbing actually have to be?
You know, to figure that out, we can't just guess. We have to think like a physicist. We need to know the train's mass, how heavy it is. We'd need to know its speed, its velocity. We'd have to see how far the webs stretch before the train stops, and of course, count how many web lines he's using. Once you have all those numbers, you can turn this movie scene into a real math problem.
So once we have all that data, what's next? Well, believe it or not, it all boils down to one simple, incredibly powerful equation. It's one of the most fundamental laws in the entire universe, and it explains everything from throwing a baseball to, a superhero lifting a skyscraper.
And if you're wondering who figured all this out, look no further than physicist James Kakalios. His book, The Physics of Superheroes, is just brilliant. He uses these exact kinds of questions to make some really complex science super fun and easy to get.
And here it is, the big one. Newton's second law of motion. Now I know it sounds all formal and stuffy, but the idea behind it is actually super simple, and it's the engine behind basically every action scene you have ever seen in a movie.
F equals m times a. That's it. Force equals mass times acceleration. So the force that Spidey's webs need to exert is just the train's mass, multiplied by how quickly he can slow it down. That's its deceleration, which is really just a fancy word for negative acceleration.
And this simple formula makes so much sense when you think about it. If something is heavier, has more mass, or if you want to move it faster, give it more acceleration, you're going to need more force. It's why the Hulk is so, incredible. The sheer mass of the things he lifts requires a mind-boggling amount of force. It all comes back to F equals ma.
Okay, so that's how we think about super strength. But what about another all-time favorite power, super speed? Let's switch gears for a second. Because when you start moving really, really fast, the universe starts to get kinda weird.
So just to give you some perspective here, the fastest any human has ever traveled was the crew of Apollo 10. They were screaming back to Earth at over 11,000 meters per second. Insanely fast, right? Well, the Flash on the CW show has been clocked at over 17,000 meters per second. That kind of speed isn't just fast, it's fast enough to actually start messing with reality itself.
And the genius who figured this all out? Albert Einstein. His theory of special relativity dropped a bombshell on physics. He realized that a weird thing happens when you approach the speed of light. Time itself starts to slow down for you, compared to someone who's standing still. It's a concept called time dilation.
Yeah, you heard that right. When the Flash is hitting his top speed, it's not just that the world looks like it's in slow motion to him. For him, time is literally passing more slowly than it is for you and me. This isn't science fiction, it's a real phenomenon, just played out by a fictional character. How cool is that?
All right, we've covered strength and speed. Now for maybe the most iconic superpower of them all, flight. It looks so easy when Superman does it, just soaring through the clouds. But the actual science of getting off the ground, it is anything but simple. See, in the real world, for anything to fly, whether it's an airplane, a bird, whatever, it has to perfectly balance these four forces. You need thrust pushing you forward and lift pushing you up. At the same time, you're fighting against your own weight, pulling you down, and drag trying to slow you down. It's a constant, delicate dance. And this, right here, is the problem with Superman. I mean, where are his engines? Where's his thrust? He doesn't have wings to generate lift. He just goes. From a physics standpoint, he's a total mystery, somehow overcoming weight and drag with no visible means of propulsion at all.
So, after all this, what's the point? We've seen heroes bend the laws of motion, warp time, and defy gravity. But this isn't just about finding plot holes in our favorite movies and comics.
The real takeaway is that these wild, fantastic stories are actually an amazing way to learn about real science.
When we analyze Spider-Man's webs, we're learning about mechanics and force. When we question how fast the Flash can run, we end up talking about Einstein's theory of relativity. And Superman? He gets us thinking about aerodynamics.
See, it's not about trying to ruin the fun. It's about using the fun to build a bridge to something real. It gets us to think critically, to ask questions about the world around us, and see the line between what's possible and what's pure imagination.
And this stuff really matters. This kind of curiosity, the kind that makes you wonder how Iron Man's suit works, is exactly what inspires the next generation of scientists and engineers. The people who are going to design real-world drones and next-gen aircraft might have gotten their start just by thinking about superheroes. So, I'll leave you with this thought. The laws of physics we talked about today aren't just for superheroes. They're happening all around you, all the time. So what's something in your everyday life, some little superpower you take for granted, that science can help you see in a whole new, amazing way?